everybody. So as always, if you like this video, press the like button. If you want to comment, then please do. If you want to share, then please share among everybody you know. And please make sure you hit that subscribe button for the latest videos and tutorials. Hi all, and welcome to this OSPF practical demonstration. So initially, we're just going to have this very quick one slide presentation. So we're going to be using two routers named Tutorial and Tutorial 1. They have an aggregated Ethernet interface labeled as aggregated Ethernet 0, connecting the two systems together. And those addresses are 192.168.100.1/30 at tutorial end and 192.168.100.2/30 at tutorial 1's end. So we'll go through the practical demonstration first, and then we'll have a look at the wireshark packet so that we know exactly what we're looking for with regards to OSPF, LSAs, and the type of area. So here we are at our configuration screen. We're going to utilize Tutorial and Tutorial 1 routers that we utilized last time. Now we're only going to configure OSPF initially on Tutorial 1, and the reason for that is we need to monitor the interface and write the information to a pcap file for opening in Wireshark to show you the full neighbor relationship process. And we'll configure Tutorial to see those packets coming in and forming that relationship. So we're going to go to Edit, and we're going to do a set routing options router ID, and we'll call it 110.110.110.110. This is the loopback IP address on this system. It's only 3 commands that we need to do. So we then do set protocols, OSPF, and we're going to use area 0, and we mark that as 4 zeros like an IP address, and the interface that we want to put into that, AE0.0. We also want to put in the loopback, so we're going to put set protocols, OSPF, area 0000, interface LO0.0, but we're going to put this in as passive. All passive means is that it will inject the network from the loopback interface, but loopback 0 will not participate in OSPF or the processes of OSPF. So let's go ahead and commit that. Now we're going to set the monitor command, but we have to go back to operational mode for this. So we're going to type in monitor, if I could spell, monitor traffic, and its interface AE0. We don't want any DNS resolutions, so we're going to do a no resolve. Packet size is normally 94 bytes, but OSPF will be larger than that, so we're going to put in a size of 5,000 just to cover everything. And then we're going to write it to a file, and we'll call it OSPF LSA. So that's this side set up ready. So on Tutorial, we are now going to start doing the configuration work for OSPF. So we go into edit mode, and it's the same 3 commands, but we're going to utilize this loopback address instead. So let's do a set routing options router ID, and we'll do 100.100.100.100. Then we need to do set protocols OSPF, and our area is going to be 0000, and the interface is going to be AE0.0. And again, we'll put the loop back in there. And the interface is LO0.0. And then we can commit this. So we're going to commit this, and then we're going to leave it for about 30 seconds. So I'm going to pause the video here and then come back to it, and then we will continue. So we can now check to make sure, firstly, that we have a full neighbor relationship. So let's do a run, show, OSPF. What options do we have? Load. So we'll just do show OSPF neighbor. And we're in a full state. So we can see this here. Okay, and this is the dead timers, as we said before. So now what we'll do is we'll go back to the presentation where we will have a look at and break down the OSPF packets within Wireshark. So here we are back at the presentation, and we're going to have a quick look at the hello packet that's from the source router, if you remember, 100, 100, 100, 100, with the active neighbor 110, 110, 110, 110. So this is the actual hello packet that's from router tutorial to tutorial 1. So from here to here. And do you remember we said the following must match for the adjacency to form. So we've got the hello interval, which the hello interval is here, and it's at a default of 10 seconds. We've got the dead interval, and the dead interval is set at 40 seconds. We have the area ID, which quite correctly stipulates the backbone area. We have the authentication data. We have the network mask, which is correct as well. And we have the area type, which tells us it's a backbone area. Now, the area type has a flag associated, and on the next slide we're going to examine that further. We can see the flag options here. We're going to expand them and examine them further. So here we see the open flags section of the OSPF Hello packet. Now, the two flags that we look for that will indicate what type of area it is, we're going to highlight now. So it's the N for NSSA and the E for external routing. Now, it's important to note that the 0 stands for a negative and the 1 stands for a positive. So in this case, this means that the area is not an NSSA and that external routes are allowed. Well, given the LSA types that are allowed within areas, so I've recapped them below, from this flags shot, we know this must be a normal area. And the reason we know it's a normal area is because of the external routing. We know it's not an NSSA because the N flag here is 0. So the 1 means this is enabled or capable. So it's the E for external routing. Let's have a look down here. External routing is an LSA type 5. So we know that that's only allowed in a normal area. So therefore, what we're looking at here, as we know from the configuration, is a normal area that just happens to be a backbone area. So let's have a quick look at what those two flags will show us from an OSPF area perspective. So we know that if E equals 1, external routing, LSA type 5, and N equals 0, which means it's not an NSSA, then it must be a normal area because that's the only place we'll see an LSA type 5. If E equals 0 and N equals 0, which means external routing is not allowed, which means LSA type 5, and it's not an NSSA, then it must be a stub area. So it's not an NSSA, but the stub area does not allow type 5 LSAs. If external routing equals 0, which means also no LSA type 5s, and N equals 1, which means it is an NSSA. You're probably wondering, well, what about the totally stub area and the totally not so stubby area? Well, they're really used for OSPF domain planning and optimization. You won't actually see them in the flags here, but you will still know that they are part of a stub or a not so stubby or a normal area. But we're going to go into that anyway in later lessons, and we'll see all of this through Wireshark traces as well. So that actually concludes the OSPF Hello packet within a Wireshark trace and the basic configuration that we completed. It was great seeing you all here. Hope you enjoyed the lesson and hope to see you in future lessons too. Please don't forget to hit that subscribe button and share this video with all your friends, family and colleagues. Bye-bye.